Good afternoon, students. Good afternoon. Am I
Good
audible?
afternoon.
Everywhere?
Yes, ma'am.
If I'm
Yes,
audible, can
ma'am.
you show me thumbs up everywhere?
Yes, ma'am.
Yes, St. Joseph's, Raibag. Yes. Chikodi, am I audible? Can you show me thumbs
Yes,
up?
ma'am.
Yes? Yes.
Yes,
Thank you.
miss. Here
Yes.
comes.
Kaylee Chikodi
Yes,
students,
ma'am.
can you tell me which are the chapters that has been covered for you in chemistry?
Solution.
Solution
Solution.
and
Ma'am. Halogens and halogens.
haloalkanes, haloines,
Halogens and haloalkanes.
Alcohol, phenol, and ether.
alcohol,
Electrochemistry.
phenol,
Electrochemistry.
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 Okay, fine.
Phenol, ether.
So that means this solution chapter has been done. Actually,
Yes,
I had
ma'am.
already started with solution. We are in some third or fourth session of the solution chapter discussion. Today, our part of discussion is what happens to vapor pressure of a solvent when we add a solute to that. And later we shall discuss vapor pressure of two liquids, of a solution containing two liquid, and then we'll discuss about azeotrophs. Now, you tell me what I have. Let's say I have a pure solvent and I have a solution wherein I have solvent, same solvent, and I have added some solute. You tell me in which of these cases, let me name this as 1 and 2, in which of these cases vapor pressure will be high?
Pure solvent
First,
1.
Pure
Pure
solvent.
solvent, right?
One. Pure
one.
solvent.
Yes, yes,
For
very good.
solvent.
So that means whenever we add any non-volatile solute, the vapor pressure decreases. In the second case, it decreases. So you know this concept. We will be discussing few questions based on this concept. Second, now I have a solution of two liquid, and whenever we have such solution and we are discussing about vapor pressure, we discuss about one law. Which is that law?
Rod's law.
Raoult's law,
Also,
very good, very good. Raoult's law. So, what does Raoult's law say? The equation, can you just tell me the equation, not the definition or statement?
P
P1
equal
is
to
equal to
P
P1
naught.
naught into
P
Chi1.
is
P
directly
naught into
proportional.
mole fraction. Yes, very good, very good. So, we will be discussing questions based on this equation as well. You know what this equation means. Now, when I speak about Raoult's law, there are some solutions which obey Raoult's law and which does not obey Raoult's law. What do you call them?
Ideal
ideal
and
and
Ideal
non-ideal.
and
Ideal
Ideal
non-ideal
and
Non-ideal.
solution.
non-ideal. Very good, very good.
Non-ideal solution.
Yes. Now, the one which obeys Raoult's law, you call it as ideal. One which doesn't obey, you call it as non-ideal. In
Yes.
non-ideal also, we have two category, right? Which are those?
Positive
Positive
deviation and
deviation and
negative.
Yes,
negative.
Negative.
very good. Positive deviation and negative deviation. Now, when I speak about azeotrophs, what do you mean by azeotrophs? Azeotrophs. Commonly, what do we call them as? Constant boiling mixture. Now, azeotrophs, are they made up of ideal or non-ideal solution?
Non-ideal.
Ideal.
No, non-ideal.
Non-ideal.
Sorry.
Non-ideal.
Non-ideal, we have minimum boiling and maximum boiling azeotrope.
Yes.
Yes,
Yes.
yes. Minimum boiling azeotropes is made by which kind?
Positive deviation.
Yes,
Positive
yes,
deviation.
Deviation.
positive deviation. Maximum by negative deviation.
Negative.
So yes,
Yes.
taking all this in our mind, we'll start our session with this MCQ. Yes. Saint Joseph, you've got cue cards. Yes or no? Yes?
Yes, ma'am.
Okay. Answer using cue card. Others, you can answer orally if you know the answer. An aqueous solution is 1 molar in potassium iodide. Which change will cause the vapor pressure of the solution to increase? Which change will cause vapor pressure to increase? Vapor pressure to increase.
we'll see. Option
Yes.
D.
Option
B.
D. Okay. I got this answer from which class? Is it from Chikkodi? I don't know.
New PU College.
New PU College, yes. Okay, thank you. Yes.
Option
Anybody?
C.
Option C, okay.
Option B.
Saint Joseph. Option B?
Chikkodi.
Chikkodi. Okay, option B. Fine. Anybody else wants to answer? Anybody from girls? I'm hearing answer only from boys. Anybody from girls?
Option B.
B? Huh. Okay. I've
Option
got
C.
option C. C. Huh. And I'm getting poll result, and poll result is like I'm getting all the options as answer from St. Joseph's poll result. The majority
Option
is with
C.
B and C. Okay. Somebody else answer? Yes?
Option C.
C. C. Okay. So now I don't know who answered. I think this is from New PU College. Can you explain your answer? New PU College, whoever answered this. Can you explain your answer? Why? If I'm asking you to explain this answer, mean you're correct. Option D is correct. Can you explain why addition of water?
By adding solute, the vapor pressure is decreases, and water is solvent,
Yes.
universal solvent.
Yes, very
Vapor
good.
pressure is increases.
Very good, very good. Look, just now when we started off this class, we discussed that when you take a pure solvent and you take a solution, solution means you have added some salt. Whenever you have added an electrolyte to a solvent, the vapor pressure decreases. Okay, now observe, we already have a solution of 1 molar Ki. Now, if I take A, B, C option, I am going to add further more electrolytes. I'm adding more solute. I'm adding extra potassium iodide. I'm adding extra sodium sulfate. I'm adding extra sodium chloride. So, if I'm adding extra solute, obviously vapor pressure should decrease. Now, instead of that, if I add extra solvent, what will happen if I add extra solvent to the 1 molar Ki solution, the concentration
Will
of the
increase.
solute decreases. The concentration of already present potassium iodide decreases. As the concentration decreases, the vapor pressure
Vapor pressure increases.
increases, right? So correct answer is option D. So always remember, if you want to increase the vapor pressure, you have to increase the solvent amount, not addition of solute. Solute will always decrease the vapor pressure. Okay, this was very simple question. Now we'll take one problem. Yes. So the vapor pressure of the solution relative to that of the pure water. So 1 mole of sugar dissolved in 2 mole of water we have. The vapor pressure of the solution relative to that of pure water.
Option D.
Option D. Okay.
Option D.
D only or B?
D.
D. Okay. Anybody else? It's St. Joseph, you're also going with option D. Anybody else from Nippani, Raibag, Chikkodi? Anybody else? No? Okay, now.
Chikkodi.
Yes? What's your answer?
D.
Are you answering? I don't know which class student is answering. Fine. If you're not answering, let me answer this question. So what is the question? They have given 1 mole of sugar is dissolved in 2 mole of water. Now the vapor pressure of the solution relative to that of pure water. Compared to that of pure water, what is the vapor pressure of the solution? Now let us take vapor pressure of pure water, let us take it as P naught. Okay. Now let us take vapor pressure of solution as P. Now whenever we take vapor pressure of solution according to Raoult's law, what do we take? Pressure into mole fraction into pressure of the pure solvent. Okay. Now what is the mole fraction of the water? How many moles of water do we have? 2, right?
2 moles.
So 2 divided by, what is the mole fraction is? The number of moles of water divided by total number of moles. Moles of water is 2 divided by total number of moles means moles of water as well as moles of sugar. 2
Sugar.
plus 1, right?
1.
So into P naught. What is this? 2 by 3 into
3 P naught.
P naught. Now they are asking vapor pressure of the solution relative to that of pure water. So we shall take this vapor pressure of solution divided by vapor pressure of pure water. So what is the vapor pressure of the solution? We've got 2 by 3 P naught. 2 by 3 P naught divided by, what is the vapor pressure of pure water? P naught. Right? So cancel P naught, what is
2
remaining?
by 3.
2 by
Option
3. So it is option A. None of your answer is correct. Option A. This was very simple, student. They're asking relative. Look, this is related to the same thing. What happens to the vapor pressure of the pure solvent when we add any solute? Now when I have added solute, how are you relating the vapor pressure of pure water to the solution? Okay. Option A is the answer. Understood? Now we'll go to next question. Now this requires some thinking. Let's see how many of you will answer this correctly. They have given solubility of sodium chloride, I guess, of a common salt, and they have taken 3 such system, and now you have to compare the vapor pressure. Vapor pressure. Think properly and answer this question. Very good question this one is.
Option B. Option A.
Option A. Okay.
Option A.
A only. Fine.
A ಅಂತ ಹೇಳಿದ್ನ? A.
ಬಂದ್ ಮಾಡು.
A. Okay.
Option A.
A. Can I know why it is option A? And like I'm getting poll result from St. Joseph as well. According to you also, majority of you are going with option A. Yes. Can I know why option A? You're answering it as option A.
D.
What is that you applied over here? Which concept? Something you might have applied, right? Is it like the gram of sodium chloride that they are dissolving is decreasing, so that's why the vapor pressure should increase? Are you applying that, or anything else you are trying to apply over here? Can I know why all of you are actually going with option A?
Because in the first system, the more number of solute is dissolved in 100 gram of solvent. So solute is more than solubility is decreases.
Okay, so that's
That's
what you applied. Who answered? Can I know who is the one answering? From where?
Nippani, Nippani class 20. Class 20.
Class 20 Nippani. Fine, fine. Thank you. So everybody applied the very same thing? I guess you have applied the very same
Yes,
thing.
ma'am.
Okay, fine. So now let us discuss this. Here they have given The solubility of common salt is 36 gram in 100 gram of water. Now this solubility, the definition, the very definition says the maximum amount of solute that can be dissolved in a given amount of solvent. Now when I say 36 gram of NaCl is the maximum soluble amount of NaCl, that means that particular solution is called as saturated solution. That means this solution already has maximum amount of solute that can be dissolved. Okay, now here they have taken three systems, 1, 2 and 3. Let me write these three systems. Now this 2 contains 36 gram, 1 contain 40 gram and 3 contain what? 20 gram. Okay, now 36 gram in 100 gram of water is the maximum amount of NaCl that can be dissolved, and I call this as saturated solution. Now come to third part. Here actually in same 100 gram of water I have dissolved less amount of solute. What kind of solution this can be? Can you tell me? If this is saturated, this could be
Unsaturated.
unsaturated. Very good.
Unsaturated.
This is unsaturated. So here I can actually add more amount of solute, but I have dissolved less. I have dissolved only 20 gram of solute over here. I would call this as unsaturated solution. Now, in first cases, maximum capacity of the solvent is actually 36 gram. But I have added extra, that is extra 4 gram. I have added 40 gram. What can I call this solution as? Anybody?
Unsaturated.
Nah, this is unsaturated. You have less than the required amount.
Super saturated.
Very good, very good. So this is super saturated. Very good. Super saturated. Now students, here comes the, here is a catch. Here is where you have to apply that. Now, here I can see all 36 gram of solute in a dissolved form. Here also I see all 20 gram, whatever 20 gram of NaCl I have added, all the 20 gram will be in dissolved form. Okay. But here, when I have added 40 gram of solute in this water, remember, the 100 gram of water can only dissolve 36 gram of NaCl. That means even if you add 50 gram, 60 gram, the soluble amount of NaCl is only 36 gram.
36.
The remaining 4 gram, what will happen to the remaining 4 gram that you have added? The remaining 4 gram will precipitate out. Remember that, you might have seen the precipitate. Okay,
Yes.
precipitate, you know, right? The one which comes at the bottom of the test tube,
Yes.
right? So this will be precipitated out. Okay, let's say you have added 50 gram. The solution can take, the solvent can take only 36 gram. Only 36 gram will be in dissolved form. Remaining whatever amount will be there, that will be in a precipitate form. Now, the vapor pressure of a solvent will be affected only by the dissolved amount of solute. Only affected by dissolved amount of solute. Now, in first case, what is the dissolved amount of solute? Anybody? Out of 40 gram, how much is in the soluble form?
36 gram.
36.
36.
Only 36 is in soluble form. In second case, we already know we have 36 in soluble
36.
form. What about in third case?
And
20.
20
gram is in soluble form. And now you apply that. More amount of dissolved non-volatile solute, less the vapor pressure, right? More solute, less vapor pressure. That means in 1 and 2, the amount of dissolved solute is same. That means the vapor pressure due to 1 and 2 will be same, right? here, come to third one. The dissolved amount is 20. 1 and 2 has dissolved amount 36. Between 1 and 2 and 3, in which case the vapor pressure will be high?
Third.
Between, look, we know 1 and 2 is same. It will have same vapor pressure. Why? Because the dissolved amount of solute is same. Now the question is, if you are comparing 1 and 2 system with third system. Sorry, this is
In
third,
option
right?
in 2.
Huh? Which will have more vapor pressure? The one which has less
Third.
amount of solute
Third
will have
one.
more vapor pressure. Very
Option
good.
C,
Third,
ma'am.
third. This will have more vapor pressure. Very good, very good.
Option A.
Option
D.
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 D, right?
D.
1 and 2 same, third has more. Very good. Option D. So this is what you have to apply. Okay? The saturated, super saturated, you kind of have to remember this and remember how much will be in soluble and the rest will be in a precipitated form. And the soluble amount will dictate the vapor pressure. Okay? So I hope you have understood this question. Very important. Okay? Application wise, this is very important. Option D is correct. Shall we go to next question?
Yes,
Understood
ma'am.
everybody?
Ma'am. Yes, ma'am.
Yes.
Ma'am.
Okay, fine.
Ma'am.
Now we shall take this one. Now don't observe this. This is not actually apt to this. This is the question. This part is question and these are option. Some liquids, vapor pressure versus temperature curve they have given. Which is the correct one? You have to apply concept. I'm going to give you one clue that you have to apply the concept of intermolecular attraction, intermolecular attractive forces over here. Based on that concept, you'll be able to answer. Diethyl ether, acetone, ethyl alcohol, water. You have studied organic chemistry, right? You know, I would say this has that concept of organic, inorganic chemistry, which we are going to apply in physical chemistry. So that intermolecular attractive forces concept is quite important. It's applicable in all part of chemistry. Option
A.
C.
C. A. Did somebody say A?
Option B. Option
B.
C.
C. B.
Option C.
Option C. Okay.
And C.
C. Fine. Huh. Any other?
Option C.
C. Okay. Fine. Saint Joseph poll result. Yes. You are going with option C.
C.
Fine. Okay. So here we have a concept. If you're taking option, if you're choosing option B and C, you're wrong. Let me explain you this. We have diethyl ether, acetone, ethyl alcohol, water. Now, actually I had explained this concept once to Saint Joseph and Nippani, I guess. I'm not quite sure, but yes, I kind of recollect. You tell me, everybody, very basic question I'm gonna ask you. Now I have water, okay, and I'm heating this. So when you're boiling or when you're heating, the liquid water, it will convert into gaseous water. Right, it will evaporate. Now when you're converting liquid water to gaseous water, do you have water as H2O, or what are you actually going to do when you're offering heat to this liquid water? Are you going to break oxygen hydrogen bonds in
No,
water?
no,
No?
no.
No? Then what are you going to break?
The intermolecular hydrogen bonding between the water
Very good. Who
molecule.
is answering? Can I know who is answering?
Nippani class 20.
Nippani class 20. Okay, thank you. Very good, you are correct. We are going to break the intermolecular attractive forces that is present between the different water molecule. Fine, good. This thought you should always have. Whenever you are evaporating any liquid into gaseous state, you are breaking the intermolecular attractive forces. You are not going to break any kind of covalent bond. H2O in liquid form, H2O in gaseous form. It will always be in that form only. H2O, H2O. Okay? The only thing which you are breaking is this intermolecular attraction. Now, you tell me, if the intermolecular attraction is strong, then is it easy to convert liquid to vapor?
No.
No or yes?
No.
No, yes, you are correct. So if the intermolecular attraction is very strong, then it is very difficult for me to break this intermolecular attraction and convert this into gaseous state. Okay? So if I have to convert this liquid to gaseous state, I have to supply high temperature. That means the boiling point of that liquid will be very high. It will require high amount of heat or temperature to convert this liquid into gaseous state. Now, if it is very difficult to convert liquid to vapor, then you tell me number of vapors or amount of vapors, will it be high or low?
Low.
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 Amount of vapors will be low. If amount of vapors are low, what about vapor pressure? Will it be high or
Low.
low? Low,
Low.
yes. Then vapor pressure will also be low. Then can I say this? Stronger the intermolecular attraction, lesser the vapor pressure. Is this correct?
Yes, ma'am. Yes,
Yes?
ma'am.
Yes.
So this is something you have to remember. Stronger intermolecular attraction, lesser will be the vapor pressure. Now, in the given question, we have 4 different compounds. Which are those compounds? Diethyl ether. Diethyl ether. This is ether. Another is, what was acetone? Acetone. Okay. Another was water, and
Ethyl.
one more was ethyl alcohol. Now I would discuss elaborately what kind of, how they have hydrogen bonding, how they have dipole-dipole moment when I discuss organic chemistry. As of now, you remember, in case of alcohol and water, we will observe hydrogen bonding. Hydrogen bonding. And number of hydrogen bonding will be high in case of water. More hydrogen bonding. Okay? In case of acetone, we will see dipole-dipole interaction. Dipole-dipole interaction. These are different kind of intermolecular forces, students. Different kind of intermolecular forces. Here dipole-dipole, here hydrogen bonding, here weak dipole. Weak dipole. Okay? Now, I will show you the order of intermolecular attraction. Hydrogen bonding is the strongest. Okay? So, hydrogen bonding is the strongest. We have 2 molecules which shows hydrogen bonding. In this 2 molecule, water has high hydrogen bonding. So, water first, then ethyl alcohol, then comes the dipole-dipole. In case of acetone, we see strong dipole. And in case of ether, we see weak dipole. Okay? So this is the order of strength of intermolecular forces. Order of strength of intermolecular forces. That means in case of water, the intermolecular attraction is very, very strong. What happens to vapor pressure now in case of water? Will it be high or low?
Low.
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 That means the vapor pressure order will be exactly opposite of this, right? So water will be having lowest vapor pressure. We shall come to this that question and check. Where is that question? Yes, here.
Option D.
Option D, is it? Check once again.
A.
A.
Yeah,
A.
right? Yeah. So A is correct. So this is A is diethyl ether, acetone is B, ethyl alcohol C, and water is D, which has low vapor pressure. Look, to convert this into vapor, we have to apply large amount of temperature, right? We have to increase the temperature. You can observe in that way also. Okay, option A is correct. Always remember about the intermolecular forces. You can generally write down this, because I will be using the very same thing in organic chemistry also. Intermolecular forces of attraction, order first is hydrogen bonding, then is dipole,
Finished.
last is very good, van der Waals. Okay, last is van der Waals. So everybody, you have to remember this intermolecular forces of attraction. Very, very, very important for both inorganic and organic. Okay, please remember this. Whenever we discuss organic chemistry, this becomes very important, the intermolecular forces of attraction. Done?
Yes, ma'am.
Yes. Okay, thank you. Now we'll take, yes, this question. Same, based on the very same concept. I mean, not the one previous question concept. The vapor pressure, what happens when it solute is added. So it is based on that. So they have given 3 solution and they're asking something about vapor pressure. Carefully
D.
observe. Yes? Somebody answer?
Then D.
Option D. Okay. Saint Joseph's. Why are you taking so much time? This is not a difficult question. Same, similar to that, 36 gram NaCl. Somehow. Nobody else. St. Joseph's, very few of you have answered.
Option D.
Option B or D?
E.
D.
Option D.
D. Okay. St. Joseph, most of you are going with option D again. No other answer?
Option C.
Shall I discuss? Okay. So now we have water and we have glucose solution. So this B is 100 ml 1 molar. How many moles of glucose are there in this solution? How do we find out that? They have given molarity. Molarity is equal to mole by volume, right? Simply if we have to write. Mole will be, how do you find out mole? Mole is equal to molarity into volume. What is molarity? 1 into, what is volume? 100 ml. 100 ml. So here in case of B, we have 100 millimole. Since we have taken in ml, the moles will be millimole, okay? In case of B, we have 100 millimole glucose, the solute, okay? What happens in C? In case of C, again, molarity into volume will give you moles. What is the molarity? 0.5. 0.5 into volume again is 100. How much is this? 50, right? 50 millimole. So here we have 50 millimole. One case we have pure solvent. Pure solvent will always have high vapor pressure. So vapor pressure of A will be very high compared to these two. Now here we have to observe how much amount of glucose is present. Here 100 millimole, here 50 millimole. Clearly B has more amount of glucose, more amount of solute means vapor pressure will decrease. So B has less when compared to C. This is the order of vapor pressure. So your answer was option D. Let's see what option D is. Vapor pressure of B is lower than that of C, and vapor pressure of C is lower than that of A. We are getting the same thing. Very good, very good. Option D is correct. You are correct. Good. So now that means you are quite good with what happens to the solution when we add a what happens to the pure solvent vapor pressure when we add a solute. Now we'll move on to that Raoult's law part. Let's see how good you people are with this Raoult's law calculation part. Yes, here we have a question. You have to find out vapor pressure of the pure B. They have given you total pressure and the moles of A and B they have taken. We have a solution of two liquids now, A and B. Simple calculation, I guess. Which is that formula that you are going to apply? Total pressure
Option B.
is equal
Option
to
B.
option B. Okay.
Yes.
Yes. This formula you have to apply. Pressure of A and pressure of B is equal to total pressure. They have given you total pressure, and this one will be mole fraction of A into this. Right? Any other answer? Look, I have given you the formula also. Very simple. Only one answer so far. Nobody else. Anybody from girls? St. Joseph? No answer
Option.
till now.
Option B.
Option B. Okay.
Option B.
B. Ha.
Option B.
B. Nobody from girls? None of you have answered from any class.
Option B.
B. Ha. St. Joseph, where is, I'm not getting your poll result.
Option B.
B. B.
Option A.
Option B.
Okay, okay, okay.
Option
All of
A.
you are going with option B. Let's see whether you are correct or not.
Option A.
Option A. So you thought, let's have a change. Let us see if option A is correct or not. Fine. Yes.
Option A.
Option A. Okay. So here we have a total pressure. What is the total pressure? Total pressure is 184. Let us substitute whatever data that has been given. And we have to find out mole fraction of A. Mole fraction of A is number of moles of A divided by total moles. Total moles is 3 plus 2, 5 into pressure of A. They have given over here, that is 200. 200 plus this one. Mole fraction of B is number of moles of B divided by total moles, that is 5 into
Ma'am 200 बरेली 20 पर.
Ma'am,
yes,
20 की तरफ
200, yes, 200, yes. So here what do we get? 40, and this one would be 184 is equal to 120 plus 2 by 5 into partial pressure of B. Now what can we do? 184 minus 120 is equal to 2 by 5 into partial pressure of B. So this one would be 64.
64.
64 is equal to 2 by 5 into partial pressure of B. Partial pressure, I am writing over here, partial pressure of B will be equal to 64 into 5 divided by 2. So this is 32 into 5. So
160.
yes, 160. 160. Good. Option B. Everybody, you have answered option B. Very good, very good. So this was an easy question. We'll solve one more such question. Where is that? Yes, we can. I think you can solve this also. Similar to the previous one. So here you have to find out vapor pressure of the solution. This is even more easy, I guess. P total is equal to PA plus PB. You have to find out this. Such an easy question.
Option C.
Option C. Okay.
Option C.
Option C. Huh? Any other answer?
Option C.
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 Okay. No other? No other option? Only C I'm getting, nobody else going with something.
Option A.
Option?
Option.
You're not audible properly.
Option A.
Option A?
Option A.
Option A.
Option A.
Option A.
Option A? Okay.
Option A.
A.
Fine.
Option.
Yes. Saint Joseph also. Option C, most of you are going with. Fine. So here we have to find out what? We have to find out total pressure, and we'll use the same formula. A into pure solvent, B into this one. So mole fraction of A, let us find out 2 moles of A. What is the total moles? 5. 2 plus 3, 5. Into, where is the vapor pressure of this? A, 120. 120. Plus, mole fraction of B would be 3 by 5 again into total
180.
180. 180. Okay. So this is 5 ones are, 5 threes are 15. So this is 36, right? So this one,
And
24, right? So this is 48 plus 108.
150.
Yes. What is the total of this?
156.
156. I don't know why you people were going with option C. So it was such a simple question, right? You just have to find out total pressure. Everything has been given. So please don't go wrong in this kind of question. You will be very lucky if you get this kind of question. Okay? Option A is correct. Option A is correct. Fine. So let us solve.
Ma'am, time up.
Okay. Fine. So yes, we'll wind up the session over here. Next class, tomorrow, we'll continue with the same vapor pressure and we'll start with colligative property, okay? Ideal
Thank
solution
you,
and
ma'am. Thank you,
colligative
ma'am.
property. Okay, fine.
Bye,
Thank,
ma'am.
Bye,
thank you,
miss.
students.
Thank you,
Bye.
ma'am. Thank you.
Bye bye, miss.
Hello, thank you.
Thank you, ma'am.
Bye.
Bye, miss.
Thank you, ma'am.
Bye, ma'am.